All right, guys, so we're starting a new chapter today, 14.1. We're going to be graphing quadratic functions. This is a little bit tamer than what we've been doing. You really need to get this first section down. It's not hard. If you get this section down, the whole chapter is going to be easy. So when we're graphing quadratics, first we have to put it in the standard form of a quadratic function, which we're fairly comfortable with, ax squared plus bx plus c. Once it's in that position, we can find out all our important points. But if you don't put it in that way, or if you don't write it in that form, then you're going to mess it up. Now, there's a couple of things in every quadratic you need to know. First, a quadratic is always a U shape, which is called a parabola, okay? You have to remember that. Anytime you see x squared in your equation, it's going to be a parabola. Now, there's a couple of important parts of a parabola. The first is this point right here. It's called the vertex. So I have a vertex in this one, and I have a vertex in this one. Now, the vertex is the point where our graph goes the other direction. Like if you look at this one on the left, it's coming down, it's coming down, it's coming down, but then it hits the vertex. Now it's going back up. Same thing in the other one. It's going up, hits the vertex. Now it's moving back down. The other thing we need to know is this dotted line here. It's called the axis of symmetry. The axis of symmetry is a line that goes through the vertex but cuts our graph in half. So one side is a mirror image of the other one. So we also have an axis of symmetry in the second one. Now you absolutely have to know those things. I could ask you on a quiz, label the vertex, label the axis of symmetry, or what shape is a quadratic function. You need to know vertex, axis of symmetry, and parabola. So now that you know the parts, let's work a couple of problems. Now, in each of these equations, or each of these problems, it's going to give us a quadratic equation. We're going to have to find three things: the axis of symmetry, the vertex, and then we're going to have to graph it. So let's look at this first one. I have y equals x squared minus 4x plus 5. The first thing we want to find is the axis of symmetry, which is found by equation. Our axis of symmetry is x equals negative b over 2a. Now, the reason it's x equals, if you don't remember, if you have x equals a number, that is a vertical line when we graph it, and our axis of symmetry is always a vertical line. So we're already in ax squared plus bx plus c form, but I need to know a and b so I can find the vertex. A is 1, b is negative 4. Now all you have to do is plug that in. So I have x equals negative times my b value, negative 4, divided by 2 times a, which is 1. Make sure and put your parentheses there because it might mess you up. A negative times negative 4 is positive 4. 2 times 1 is 2. And 4 divided by 2 is 2. Now the axis of symmetry, since it is a line, you can't just write 2. You need to say x equals 2. That shows that it's a vertical line going through x equals 2. Now once you found your axis of symmetry, you now can find your vertex. You've got to find your axis of symmetry first. So when we do our vertex, it's a point. And the point, is negative b over 2a gives us the x value, and then we need to find the y value. But what's great about that is we already found negative b over 2a, and it's 2. So the x value in my vertex is 2. Now if I know x equals 2 and I need to find a y value, I can plug that 2 back into my equation and solve for y. So on the vertex, you're going to use the x value from the axis of symmetry. And you're going to plug it back into the equation, and plug into the equation. So half the work's done for us once we find the axis of symmetry. The other half is just plug it into the equation. I'm going to have y equals, well, it's x squared, so 2 in parentheses squared, minus 4 times x, which is 2, minus or plus 5. Now you can put that straight into your calculator. Shouldn't be that hard of a deal. Use your parentheses. 2 squared minus 4 times 2 plus 5 gives us 1. So our vertex is the point 2, 1. So those two things are basically formulaic. You just got to plug two numbers in and get the rest. That shouldn't be too hard. You absolutely have to be able to do this. Now let's go to the next page and finish up the first problem. Now it left some of the stuff on the other page, so I'm just going to rewrite a few things. First, our equation was y equals x squared minus 4x plus 5. We found that our vertex was 0.21, and our axis of symmetry was x equals 2. So when we want to graph, we have to use that vertex and axis of symmetry first. So I'm going to move over to my graph, and I'm going to plot my vertex point over 2, up 1. Then I want to draw on my axis of symmetry. It's a vertical line through x equals 2. So I'm just going to draw kind of a dotted line that goes down. I don't want to think it's part of my graph because it's really not. It's just going to help me plot the rest of my points. Now C is the last thing we have to do. We need to find a point, and then we're going to use our axis of symmetry to reflect that and get a second point. The way you do this is you pick an x value. You don't want to pick a super big or super small x value, probably something close to what your vertex or axis of symmetry was. The easiest point to always use is x equals 0 if you can. Now I'm going to plug in 0 into my equation to get the y value that goes with it. So one of my points is going to be 0 something. So I'm going to take that 0 and plug it in. So I have y equals 0 squared minus 4 times 0 plus 5. Now 0 squared is 0. Negative 4 times 0 is also 0. So all that leaves us with was 5. So I know that one of my points is 0.05. So we picked an x. So pick an x and plug in to find y. Now we can plot that point. So I'm going to go over 0, up 5. 1, 2, 3, 4, 5. And I'm going to plot that point. Okay? Now the last step is we need to find that other point. And the way you do that is by using a reflection. If I look at the point I just picked, if I go over 2 spaces, I'm at that reflecting line, the axis of symmetry. So if my point reflects over that line, I simply have to go 2 spaces on the other side, and I can plot my second point. Now I want to check and see what that is. It's 1, 2, 3, 4 over 4 up 5. So our second point is 4, 5. Now once you've done that, we can sketch it. Now remember, it's a U shape, not a V shape. It needs to look rounded. So I'm going to start at the vertex and kind of curve one up through the first point, and then start again and go on the other side and curve it up the second. Doesn't have to be perfect, but it needs to look curved. Now the last thing we have to do is find domain and range. You need to remember that domain are the x values, or the left to right. If domain's the x values, then range must be the y values, which is bottom to top. So let's look at our x values. I want to see how far left and right it goes. Now the thing about a parabola is these arrows mean it keeps going. So it's going slowly to the left and right, but it's going to go that way forever. There is no x value I can't plug in. When that happens, and it always happens on a parabola, your domain is all real numbers. You can either write it out or you can use the symbol. There is no x value I couldn't plug in and get an answer. Now range is different. It's bottom to top. Now I can't see how low it goes or how high it goes, but I know it goes this low, okay? So range is related to y. Now the point that or the number you're always going to use is how low I can tell it goes, or how high if it's flipped the other way. So I can tell that it's related to 1 in some way. If you notice, 1 was our y value in our vertex. So all you have to decide, are my y's getting bigger as we go along my graph or smaller? Since they're all above that line, y is bigger, but y can be 1, so it's also equal to 1. Now be careful on domain and range. Domain on quadratics is always all real numbers. The range is always y, and the y value in your vertex. You just have to decide which direction. All right, let's try another one. So let's do number 2. I have the equation y equals negative x squared plus 2x minus 1. I need to find the axis of symmetry, vertex, and graph it. So I know I need to find an a value and a b value, and luckily it's already in the form we need. A is negative 1, b is 2. So you might pause for a second if you're watching this, try to find the axis of symmetry. Remember, it's x equals negative b over 2a. So I'm going to go ahead and plug it in. It's negative times b, which is 2, divided by 2 times a, which is negative 1. A negative times 2 gives me negative 2, and 2 times negative 1 is also negative 2. Negative 2 divided by negative 2 gives me 1. So my axis of symmetry is x equals 1. I'm going to go ahead and sketch that on my graph. Let's see, it's x equals 1, so it's a vertical line going through positive 1. So there's my axis of symmetry. Now we need to find our vertex. Now remember, the vertex point is what we used, or the x value is what we just found. So in this case, it's 1. But we need to plug that into the equation to find y. So I'm going to put plug in. This time it's y equals, I have negative, then I'm going to plug something in there squared, plus 2 times some x value, and then it's going to be minus 1. So the number I'm going to plug in is the 1, and then I can pretty much just use my calculator from there. 1 squared plus 2 times 1 minus 1 will give us 0, so our vertex point is 1, 0. So I'm going to go over to my graph, and I'm going to go over 1 up 0. I'm going to plot a point. If you graphed your axis of symmetry already, your point should be on that line, so if it's not, you may have messed up. So now, excuse me, I need to find one point by picking an x value, plug that in to get the y value. Now I told you last time x equals 0 will work very well, but you didn't necessarily have to use that point. I'm going to use it again just because. So I'm going to say I'm going to choose x equals 0, so there's my first point. Now I just have to plug it into my equation. I have y equals negative times something squared plus 2 times something minus 1. Well, I'm plugging in 0 to both of these, and just like last time, and why it's so easy to use is 0 squared is 0, 2 times 0 is 0, and that gives me that my y value is negative 1. So I'm going to go over and plot 0, negative 1, which would be about right here. So I need my second point, though. So I'm going to go back up here, and I'm going to look. I know this point right here is 1 unit away from my line of symmetry, so I'm going to go 1 to the other side. I'm going to mark my second point. Looks like it's over 2, down negative 1. And notice how when I reflected, I got the same y value. So now that we have our 3 points, I can graph it. I'm going to make it nice and curved, or at least the best I can. And there's your parabola. Now you notice this one opened down instead of up. If you look at the first one, our x squared was positive, but on this one it's opening down and our x squared is negative. So a positive x squared opens up, a negative x squared opens down. Now we need to find domain and range. I'm going to write it here so I don't have to lose my graph. Remember, domain is our x values, and if you look at that graph, it's going to keep going left and right forever. So again, our answer is all real numbers, or just that symbol. Now range again deals with y, and the y value in our vertex, which it looks like is 0. Now if I look at my graph, here's 0. My y values are below it, so that means my y values are all smaller than 0, but is also equal to 0. Now guys, if you're having trouble with domain and range, you need to come talk to me, but the other parts are just plugging things in. You have got to know this. If you do, the rest of the chapter is going to be easier. If you don't get this now, it's only going to get worse. So good luck. If you have any more questions, just let me know.